It's a recording, so I can't have like the fun conversations anymore. Celebrity professor? Should I get Drake in here to teach the next calculus? Okay, this is implicit differentiation. I don't mean no disrespect, though. Disrespect, okay? That's me lecturing as Drake. That's my absolute favorite part of watching these Raptors games. When like they're on the news, they're like, we're breaking in with a response from Drake. Right? And then they go to Drake. It's like, why do I care? Huh? At least people are aware of Canada. That's my...
Sir, this is really important.
Huh?
Do you know who Nam Bhatia is?
Who? Who?
You don't know who Nam Bhatia is?
Oh, yeah, that's always the
He's the super fan.
Oh, yeah, the Sikh fellow. Yeah, he's awesome. Right?
He's
What?
the father.
Isn't he Sikh?
Yeah, he is. He is.
Someone going to report me to the diversity office now? Like, aren't I allowed to notice these things? This is a fact, right? Yeah, he's awesome. I like him because he's been going to these things since 1995.
Yeah.
I would be selling those tickets. Fuck that, right? Okay, yeah, okay. For $16,000, I'll sit this one out. Watch it on Reddit, right? Okay, we're gonna do something called implicit differentiation now. All right, so I hope you understand that. Like, I've stopped showing you geometry. I've stopped trying to develop things. We're just like flat out now just doing algebra. I just have to make sure this is recording. If it's not, then it didn't happen. All right, so all the things we've been taking derivatives of, what have they been? They've been very special mappings. They have been functions. We're only taking derivatives of functions, right? I've never given you something like this. Okay? This isn't a function, right? It's not a function because it fails the vertical line test everywhere but here. However, we could still get a tangent line here, right? The tangent will exist. We could do the same thing with limits and develop it. This actually is the curve. What was this? X cubed plus y cubed minus 9xy is equal to 0. Okay, so we need to be, so here's a shape. Its graph is this, and I still want to be able to find tangent lines on it. All right, so now we're going to have to develop an algebraic framework for doing this. So I don't know why I started with this example. I should have started with an easier one. So let's start with a circle. Okay, so we have a circle. Yep, it's almost a circle. And like we can definitely get the tangent line here if we want. So let me just make this point an easy one. 1 over root 2. 1 over root 2. All right, so I think the slope of that line should be 1. So what do we want to do? We want to find dy dx, and then we want to evaluate this at that point. 1 over root 2. 1 over root 2. Okay, so the nice thing about functions is that you have x, you have y. Right, so we never really work with y when working with functions because you got one, you got the other. These functions that are defined implicitly, you no longer have a nice relationship between y and x, right? If I asked you what was the x value here, there's 2 of them, right? So that's why we sort of say, well, I don't like working with that because there are 2 places. Okay, but we could say, so unlike on a parabola, right? I just say, give me the slope at x equals a, right? Because that gets you here. On these implicit graphs, we're going to have to specify an actual point P. Right? I say I want the tangent line here. I don't want this one. I want this one. All right. So we're going to use this. Okay. So what's the equation of a circle? I guess this one is the circle of radius 1. Can someone spit it out for me? Equation of the circle. Mumble mumble plus mumble mumble is equal to mumble squared. Okay. That's the equation for the circle. So here's the new problem. This is an equation, right? It has an equality in it. I want to give this a name, but I can't say this. Right? This is the chain of equalities. So what I'm going to say instead, I'm just going to put a colon here, right? F is this equation. Okay, so now I'm going to say something like, this means the derivative of f with respect to x is this. And I'm going to use chain rule. Okay, so what's the derivative of this with respect to x? 2x. I'm going to just write the chain. So technically speaking, even the x chains. But the x chains to dx over dx, which is 1. Right? So we don't write it because it's 1. But I'll put it there for the time being. What about the y? What do we got on the other side? So what's the derivative of y with respect to x? Or the y squared? 2y. And then what? Yes, perfect. That's just the chain rule. It's more generalized, right? Because I'm just doing it in something called y. Okay. Sorry, that shouldn't be an equal. That should be a colon. And this was all equal to 0, correct? Because that 1 squared goes away when we take the derivative of it. It's a constant. What am I looking for? I'm looking for dy dx. So here it is. So I'm just going to rearrange, and I'm going to get dy dx is equal to what? Minus 2x over 2y. Yeah? So what does this say that the derivative of y at this point is? 1 over root 2. 1 over root 2. That's equal to minus 2 over root 2 over 2 over root 2, which is what? Minus 1. Everyone follow that deduction? Does this, okay, so remember, we have to sniff now, right? Does this make sense? Because we drew a picture at first, right? I did. It smells like chalky. The slope is negative here, right? That slope is negative. This seems like a sensible result. If I did this and I found that this was positive, I have to say, okay, I have to have done something wrong, right? There's no way that the derivative here could be positive. Maybe I accidentally found this one, right? But see, to find the derivative down here now, this is a different point. This is the point 1 over root 2 minus 1 over root 2. So if I put it through here again, you'd end up getting a positive there. So see, here's an equation that actually lets you get the slope of the tangent at any of these points. The difference is you have to specify the point. Right? Because we don't have functions. You really have to give me x and y. On functions, giving me x also gave me y, implicit. So this is a technique called implicit differentiation. This is all really I have to teach you about this. So we're going to do a few more examples. But essentially, you just have to take derivatives over these equations and make sure to apply the appropriate chain rule when you're working with y. But again, it's not too tough, right? You'd be wise to invest a lot of time studying now because the first half of the course is easier than the second half of the course, and you want to destroy those midterms. Right, so the next one is going to be mostly differentiation. Okay, so now I want to investigate derivatives on this guy. So let's try to get a rule for the slope of the tangent at an arbitrary point, and I'm interested to know what happens at that crossover point. That crossover point is at the origin, actually. I didn't draw it too properly. So this point right here, actually, is the point 0, 0. Right? If I put 0 into here, you can see that it's a solution. Right? I hope that this is how you're interpreting this, right? Like, this gives you a point xy, and if I put that xy point into this equation, you get 0. That's what the graph is representing. Okay, so let's look at that guy. Okay, so let me just call this an example. Okay, so you have y, nope. So I have this equation, which I'm going to call f, which is x cubed plus y cubed minus 9xy, which is equal to 0. I'm going to say, let's take the derivative of f with respect to x. You actually can do it with respect to y now as well if you want. What do we get? So we get 3x squared times the chain rule, which you don't write, but I'm writing today, plus this, which is 3y squared times dy dx. That's the chain. Okay, let's do this. What do I do? I'll settle for the rule that I have to use. Oh, what's the derivative of this? Will someone take a stab? Well, could you take the derivative of this? Well, what would it be? What about this? Okay, but so didn't I tell you how to take derivatives of stuff that are multiplied by one another? Product rule. Okay, I'll use the product rule. Right, but you have to understand, like, this is the product of two things. You know how to take the derivative of absolutely everything, provided you apply enough rules to get it to a point where you can actually take the derivative. So you should see this as a product. Right, it's a product. Ah, yes, I like those sounds. Ah, I hear those light bulbs going off. Okay, so let's do product rule. So it's the derivative of the first times the second, and there's a minus here, so I'm just going to put that minus there, plus the derivative of the first times the derivative of the second. And this is going to be equal to 0. Okay, so what we're trying to find, so that's 1, this is the slope, right? So we want to isolate these. So let's do that. So usually what I do here is this. I write the term that I want to isolate, and then I just find what it's being multiplied by. So you've got a 3y squared and a minus 9x. And then I'm going to move everything to the other side. So what do we get moving to the other side? Well, you get a minus 9y. So if I move that to the other side, you get 9y. And then we got this guy, which is going to be a minus 3x squared. Okay? This means, right, that dy dx is equal to 9y minus 3x squared over 3y squared minus 9x. Okay, so where do we not get the slope? So here's an equation. It's saying you give me a point, I'm going to report back the slope of the line. If we look at that picture up there, remember what I said, that like if something gives you two answers, it's going to be broken essentially. Where is it not well defined what the tangent is? Yes, sir.
Is that point 0, 0?
Yes, 0, 0.
So for any x greater than 0?
It won't be defined?
No, like it won't work.
For any x greater than 0?
No, well, oh no, until that function ends.
Okay, so I'll draw it again on this board maybe. So we got a function that looks like this. That's really how it was supposed to be drawn. So you're telling me that, that there's no tangents over here?
Well, it would provide two answers, wouldn't it?
No, because you specify the whole point, right?
Oh.
So you say, I want it here, and it will give it to you.
Oh.
Right? You say, I want it here, and it will give it to you. Right? Because look, this is why there are both x's and y's in here. Because it's saying, look, you need to give me more information now. You got to tell me exactly the point you want. So let's see if you got it, sir. Yeah?
Is it the point 0, 0?
What's the tangent there? You got this. It's two tangents. Right? So we don't know which one to pick. So is it the case that this won't report anything at 0, 0? Yeah. So the geometry and the algebra sort of have an interplay, right? So we shouldn't expect. So actually, this is what I did for my PhD dissertation. I can calculate these with a computer. It's more impressive than you think. So give that a look. Okay, one more maybe. So here's a funny graph. It looks like this. Okay, and the graph actually is given by y squared is equal to x squared plus sine of xy. Okay, so we should be able to develop a formula for getting tangents along here everywhere but where? Yeah, so these crossover points are a huge problem, right? Okay, so let's get dy dx. Okay? So what do? I have to take the derivative of that. So this implies 2y dy dx, that's the chain, is equal to 2x dx dx. I'm not going to write it. Plus, now help me with the sign of xy. It's chain rule, right? This is the beginning. This is from the lecture before this. So what do we do? What did I teach you? What's the first step? Find the outermost function. What's the outermost function? All right, I just cover this up. I say, how do I take the derivative of that? Cos. Okay, so it's cos of xy. And okay, then I'll just do this. Then we have to multiply by xy prime, right? That's, well, actually, this is why we need the two pieces of a notation, because actually I have to specify that we have to take the derivative with respect to x, right? Because we may do this again. You can do this with respect to y. Maybe I should do that afterwards, because that's definitely how we'll probably try and trick you on your exam, right? By just telling you to take it with respect to a different axis, and it will screw all of you up. Okay, so we'll do that one afterwards. Okay, so let's just finish this one. So what's the derivative of xy? I'll settle for the rule that you would use to do it. Product rule. Okay, so we're going to get 2x plus cos of xy times derivative of the first times the second plus the first times the derivative of the second. Okay, and then what you got to do is you just you find all of your dy dx's, and this is all equal to 0. Right, and then you just have to isolate for that term. All right, so let's do it a different way. So what happens if I want to get, right, so this is calculating the slope by keeping y fixed and moving x a bit and seeing what happens. Yes, sir?
Is that equal to 0? It's equal to 2y dy by dx.
What have I done? You are correct. It's not equal to.
Okay.
See, that's the danger with, damn it. Yeah, you were right. Sorry, let me erase this. Let me erase this. Well, you guys should be used to this at this point.
I didn't write anything down.
So this is equal to, 2x plus cos of xy. All right, y plus x dy dx. Okay. Thank you for pointing that out. Yeah, it wasn't equal to 0. It's equal to this. Yeah, so here, there and there. You just isolate for those, and you got it. I'm not going to do it. That's kind of boring. Okay, what I do want to do is I want to get this, dx by dy. Right? You can do that. It's just, you're just sort of inverting the rise and the run. It's just like sort of taking the graph and flipping it. So I could do that as well. Okay, so we're going to start with, okay, so this was 1. This will be 2. So what's the derivative of this with respect to y? Or I need to take derivatives with respect to y. So what's the derivative of this with respect to y? 2y. Right? It is as obvious as you think. Don't overcomplicate it. This is one of the basic ways we try to confuse students who are writing midterms. We'll swap the variable. Right? You're so used to doing it with x that you're really uncomfortable if we swap it out. So you got to overcome this sort of anxiety because we're going to do it on purpose. Just switch the variables. Okay, so the derivative of this with respect to y is going to be 2y, and I'll just write it, dy dy. Right, that's why those sort of pop out. What do I get on the other side? We get, okay, so now we have to treat this differently. This is going to be 2x times dx by dy. So far, so good. And then I got to add to it the derivative of this with respect to y. That's still going to be cos xy, but now the derivative is going to be different. It's going to be the derivative of x with respect to y times times y plus x times the derivative of y with respect to y. It's going to be a little bit different. So this is 1. This is 1. So you want to isolate for this, and you want to isolate for this. I could even say take the derivative of this with respect to t, assuming x and y are functions of t. Okay, so this is really just a technique, right, for isolating the slope on implicitly defined functions. You just need a little bit of practice, right? So, because in order to do this, you have to have a really good understanding of chain rule, because stuff always chain out. So I had sort of another example that was really messy, but I'm going to give it to you as an exercise so you can have the full solution. And then I'll give you a bunch more exercises. So is there any questions before I sort of just give you some exercises and then we'll just work for the rest of the period? Like stuff that should be on video, otherwise I'll stop it. All right, so we can shit on Drake some more. I'll write the exercises on the board first, but feel free, you're released. You can talk and stuff like that. I'm just doing it for those people at home. So just to reiterate, I'm never going to ask you a question like this on a midterm. Okay? I'm going to ask you a question like this on the midterms. It's basically the same thing, right? I'm just saying do this calculation, but first you got to understand that that's what I'm asking you to do. I'm going to get E in here. Oh, and there's a worksheet too.
Are you gonna take those things? Do you have Jada's house? Right now. I had her. Oh my god, yes. She is start. She's like, this is gonna be like, don't worry about it. Don't even look at it. It's literally worth 30 marks on Oh no, and it's 7.
Hey, I had a question regarding the notation dy to dx.